Ever get kind of frustrated talking to those AI chatbots? You know, the ones supposed to be so smart, but then like two questions in, completely lose the plot.
Haha,
It's
yeah.
like they got the memory of a goldfish or something.
Mm.
Well, get this. Researchers are working on AI that can actually hold conversations like, back and forth.
Like we are right now.
Exactly. Welcome to a deep dive into the world of multi-turn conversational retrieval augmented generation.
Yeah, we'll stick with multi-turn conversational RAG for short.
Okay, good call. Much easier.
Wow.
But what is that?
So the idea is actually pretty simple. It's all about making AI smarter by giving it access to external knowledge.
Okay, so instead of just relying on what it's already been programmed
Mhm.
with, it can pull in information from the real world to answer our question.
Exactly.
Okay, so that makes sense. But I gotta admit, even with all this hype around AI, most of the chatbots I've encountered can barely answer a single question, right? Let alone have a real back and forth.
Right.
So what makes multi-turn conversational RAG different?
Well, it's all about building AI that can actually remember what you talked about and follow your train of thought and even anticipate where the conversation's going next.
So give me an example, like how would that work in practice?
Okay. Imagine asking about something like climate change and getting a comprehensive answer that's backed by real scientific data, right?
Okay, yeah.
And then you follow up with a question about the specific impact on coastal cities, and the AI would seamlessly connect the two, providing even more specific information.
Oh, wow.
That's the idea.
That would be incredible. It'd be like having a conversation with an actual expert who has all the facts and figures right there at their fingertips.
Yeah,
But how do we even begin to teach AI to do that? It just seems like such a monumental task.
it is. And that's why researchers have developed this fascinating new tool. It's called Coral.
Coral. Yeah.
And it's a benchmark data set that's specifically designed to test and train these multi-turn conversational RAG systems. And get this, it was built using Wikipedia.
Wikipedia. Okay, now I'm intrigued. But Wikipedia is massive.
Yeah.
How'd they turn an entire encyclopedia into a training ground for conversational AI?
So it's all about turning information into a dialogue.
Hmm.
Think about Wikipedia's structure. You've got headings, subheadings, and then paragraphs of text with references.
Yeah.
And they cleverly transformed those headings and subheadings into questions and the text underneath into the answers, with the references serving as evidence.
So they basically took Wikipedia's hierarchy and turned it into this giant Q&A session.
You got it.
Okay, that's clever.
And to make it even more realistic, they actually used GPT-4, which is one of the most advanced language models out there,
Right.
to make those questions sound natural, like something you or I would ask in a conversation.
Wow. Okay, that's seriously impressive. So
Sure.
how they actually go about selecting content from Wikipedia for this Coral data set? I mean, was it just random pages or did they have some sort of strategy?
They definitely had a strategy. In fact, they came up with 4 distinct approaches to building these conversations, each with increasing complexity.
Okay, I'm all ears. Break it down for me. What's the first approach?
The first one's called linear descent sampling. Imagine you're researching a specific topic, let's say the history of the internet. You might start with a broad question like, what is the internet?
Right, yeah.
And then follow up with more specific questions like, when was it invented?
Yeah.
Or who are the key figures involved? Linear descent is like following that path of increasingly specific questions.
So it's like going down a rabbit hole on Wikipedia. Each click leads you to a more detailed page on the same topic.
Exactly. Now, the second approach, sibling-inclusive descent sampling, that's where things get a bit more conversational. Instead of just going down a single path, we branch out to explore related subtopics. Let's say we're talking about the impact of social media. We might start with its effect on politics, then jump to its role in marketing, and then explore its influence on mental health, all within the same conversation.
So it's like having a more natural conversation where we can jump back and forth between different but related aspects of a topic.
Precisely. Now, the third approach, it's called single tree random walk, and it mimics how a lot of us actually browse Wikipedia.
A bit randomly.
Yeah, a bit randomly, just following our curiosity.
I'm definitely guilty of that. One minute I'm reading about the history of chocolate, the next I'm somehow learning about the migratory patterns of monarch butterflies.
Uh-huh, exactly. That's exactly what single tree random walk is all about. It allows the AI to jump around within a single Wikipedia page, simulating that kind of free-flowing exploration.
That's a really cool way to capture that natural curiosity we all have. So what's the fourth approach? You mentioned it was the most challenging one.
Yeah, this one's called dual tree random walk, and this is where things get really interesting. This approach actually simulates true topic shifts in a conversation. Imagine you're starting with a discussion about the history of space exploration.
Okay, yeah.
And then suddenly you pivot to a debate about the ethics of artificial intelligence.
Whoa, that's quite a leap. How does the AI handle such a drastic change in subject?
That's the challenge. Dual tree random walk forces the AI to jump between two completely different Wikipedia pages.
Wow.
Mimicking those real-world moments when a conversation takes an unexpected turn, it has to find relevant information from both pages, connect the dots, and provide insightful answers, all while maintaining a coherent flow.
Okay, that's starting to sound a bit like magic. So they've built this incredibly complex and diverse data set, Coral, using these 4 different conversation building strategies. But how do they actually use it to test and train these AI systems? What are they looking for?
That's a great question. It's not just about building conversations, it's about evaluating how well AI can actually handle them. And that's where the real testing begins.
Well, you've definitely piqued my curiosity. I'm on the edge of my seat waiting to hear how they put these AI systems through their paces.
All right, let's get into it. So they've created this amazing data set, Coral, and it's like a training ground for conversational AI. But to really push these AI systems, they design specific tasks that mimic like real-world conversation challenges.
Okay, that makes sense. It's not enough to just like have the information. You also need to know how to use it, right,
Yeah.
effectively in a conversation. So what kind of tasks are we talking about here?
So the first one is called conversational passage retrieval. It's all about testing the AI's like research
Okay,
skills.
so like giving it a research assignment and
Oh,
seeing if it can actually find the right info.
exactly. Imagine you're having a conversation about the history of electric cars, and you ask the AI, what were some of the early challenges in developing electric vehicle batteries?
Okay, that's a pretty specific question. I wouldn't even know where to begin, like, looking for that information.
Exactly. And that's the challenge for the AI. It has to sift through mountains of data, all of Wikipedia, and pinpoint the exact passages that contain the answer to your question. And it's not just about finding any mention of electric cars or batteries. It has to understand the context of the conversation, the nuance of your question, and then retrieve the most relevant information.
Wow, that is a tall order. It's like finding a needle in a haystack, but the haystack is, like the entire internet.
Yeah.
So how do they measure how well the AI actually does on this task?
They look at things like precision and recall.
Precision and recall, okay.
So precision means out of all the passages the AI retrieved, how many were actually relevant to the question? And then recall means out of all the relevant passages that actually exist, how many did the AI manage to find?
Got it. So it's a delicate balance. You want the AI to be both accurate and comprehensive in its search, right?
Yeah, exactly.
Like a research assistant
Yeah.
who's both thorough and efficient. You don't want them bringing you like a stack of irrelevant papers,
Right.
but you also don't want them missing any crucial information.
Hmm.
Okay, makes sense. So what's the second task?
All right, so the second task is called response generation. Once the AI has found that relevant information, can it actually use it to like craft a good answer?
Ah, so it's not just about finding the facts. It's also about communicating them effectively.
Right. It has to take those retrieved passages and like synthesize them into a clear, concise, and easy to understand answer. And it has to do all of that while maintaining the flow of the conversation, referencing previous turns, and sounding like a human expert.
Oh, wow. So it's not just like spitting out a list of facts or like a dry Wikipedia entry. It has to weave them into a narrative that makes sense within the conversation.
Absolutely.
Wow. Okay, that's impressive. So the AI's response should be both informative and engaging, accurate, of course, but also like presented in a way that keeps the conversation going. Makes sense.
Yeah.
If the AI just gives me like a robotic answer, it's going to feel like I'm talking to a machine, not having a real conversation. So what's the third task?
All right, so the third task is perhaps the most crucial one, especially these days. It's called citation labeling.
Okay, citations. Those little footnotes that tell you where the information came from. I can see why those would be important in like an academic setting. But why are they so crucial for conversational AI?
Because in a world where anyone can say anything online, it's more important than ever to know where that information is coming from.
Right.
If an AI is telling me something, especially something that I might not know much about, I want to know, where'd you get that information? Can I trust the source? Is it biased? Is it outdated?
So it's about transparency and accountability. The AI needs to like show its work, so to speak, so we can evaluate the credibility of its claims.
Exactly. And that's what citation labeling is all about. The AI has to be able to point to the exact source of its information, whether it's a specific Wikipedia page, a scientific journal article, a government report, whatever it may be. And this allows us to verify the AI's claims, trace back the origins of the information, and make informed judgments about its accuracy.
Okay, that's essential, especially when we're talking about sensitive topics or like complex issues, right? We need to know that the AI is getting its information from reputable sources. So they've got this amazing data set, Coral, and these three like rigorous tasks: conversational passage retrieval, response generation, and citation labeling.
Yeah.
What have they actually learned from testing different AI systems on this?
Well, the findings have been pretty revealing and, in some cases, even surprising. For instance, when it comes to finding relevant information, that conversational passage retrieval task, both dense retrieval and query rewriting methods have proven to be quite effective.
Okay, break it down for me. What are dense retrieval and query rewriting, and like how do they work?
Think of it this way. You're asking the AI a question, and it has to search through this massive amount of text to find the answer, right? Dense retrieval is like looking for clusters of words and phrases that have similar meanings. It's about understanding the underlying concepts and finding passages that match those concepts. Query rewriting, on the other hand, is like taking your question and rephrasing it in a way that's more likely to match how the information is stored in the database.
Okay.
So it's about optimizing the search query itself.
So it's like two different search strategies. One focuses on meaning, the other one focuses on wording. That's fascinating. What else have they learned from these tests?
Well, here's a surprising finding. In some cases, fine-tuned open source language models actually outperformed commercial models like GPT 3.5 in these retrieval tasks.
Hold on. So you're telling me that smaller, publicly available models can sometimes be better at finding the right information than these big, expensive proprietary models. How is that possible?
Well, it suggests that bigger isn't always better when it comes to AI. It's not just about the size of the model or the amount of data it's been trained on. It's also about how the model is trained and fine-tuned for specific tasks.
Okay.
These open source models, even though they're smaller, they've been carefully optimized for these retrieval tasks, and in some cases that gives them an edge.
That's a game changer. It means that innovation in conversational AI isn't limited to these big tech companies with massive resources. Smaller teams, independent researchers, even hobbyists can contribute to the advancement of this technology. This is truly democratizing AI. What other insights have they gained from these tests?
One of the most interesting findings is that shortening the input given to the AI can actually improve its performance.
Wait, are you saying that giving the AI less information can actually make it more accurate? That seems kind of counterintuitive.
It does, right? But think about it this way. When you're having a conversation, do you remember every single detail from the beginning?
Probably not. I tend to focus on the most recent parts of the conversation and maybe a few key points from earlier on.
Exactly. And that's what researchers found with these AI systems as well. When they filtered out older parts of the conversation, the AI didn't lose track of the topic. And in some cases, it even improved the accuracy of citation labeling.
So by removing some of the clutter, the AI could focus on the most relevant information and provide more precise citations. It's like decluttering your mind so you can focus better. Amazing. What other discoveries have been made?
Well, as you might expect, they found that bigger AI models, the ones with more parameters, generally performed better. But there's a point of diminishing returns. It's not just about throwing more computing power at the problem.
So size isn't everything in the AI world.
Absolutely. The quality of the training data and the way the model is fine-tuned, all of that plays a significant role as well. And here's another key finding. Fine-tuning the AI on conversation-specific data is absolutely crucial, especially when it comes to handling those longer conversation histories.
So it's like giving the AI a crash course in the art of conversation, teaching it the nuances of back and forth dialogue, how to stay on topic, how to smoothly transition between different subjects.
Precisely. And they found that this fine-tuning significantly improves its ability to handle those complex multi-turn conversations.
This is all incredibly fascinating. I'm starting to see how these tests in this Coral data set are really pushing the boundaries of conversational AI. It's not just about answering individual questions. It's about creating AI systems that can truly engage in meaningful multi-turn conversations with us.
And that's what's so exciting about this research. It's paving the way for AI that can not only retrieve information, but also synthesize it, understand context, communicate in a way that feels natural.
It's like having a research assistant, a debate partner, and a knowledgeable friend all rolled into one. This has been such an eye-opening deep dive. I'm already thinking about all the ways this technology could transform how we interact with information, and even with each other. Before we get too carried away, let's take a step back and recap what we've learned today about this groundbreaking
That
research.
sounds good.
Okay, so we started by diving into the world of retrieval augmented generation. That's where AI can actually access external knowledge to power its conversations, right?
Right.
Then we explored the unique challenges of multi-turn conversational RG, where the AI has to keep up with topic shifts, manage these long conversation histories, and provide detailed cited answers. And that's where Coral comes in.
Right, this incredible benchmark data set. Built from Wikipedia, it's transforming how we test and train conversational AI. And remember those 4 conversation building strategies: linear descent, sibling inclusive descent, single tree random walk, and the mind-boggling dual tree random walk.
Oh, yeah.
All of those, they create these diverse and challenging conversations that really push these systems to their limits.
Right. And through these rigorous tests, researchers have made some remarkable discoveries. They found that sometimes smaller open-source models can actually outperform their bigger commercial counterparts. They've learned that giving the AI less information can sometimes lead to more accurate responses, and they've confirmed that fine-tuning on conversation-specific data is crucial for navigating the complexities of multi-turn dialogue.
It's all about training the AI to think more like a human, right?
Right.
Understand context, remember key points, smoothly transition between topics. It's about building AI that can truly engage with us in a natural and meaningful way.
And with that, we wrap up part 2 of our deep dive into multi-turn conversational retrieval augmented generation. But don't go anywhere, because in part 3, we'll be exploring some of the potential applications of this technology and discussing what the future holds for conversational AI. See you there. Welcome back to the final part of our deep dives into multi-turn conversational retrieval augmented generation. We've uncovered the mechanics behind this revolutionary technology. We explored how researchers are actually training and testing these AI systems. And now, it's time to look ahead.
Yeah.
We've talked a lot about the how,
Right.
but now let's delve into the why. What's the big deal with multi-turn conversational RAG? What kind of impact could this actually have on our lives?
So we've been on this incredible journey.
Yeah.
But where does it all lead, right? What are some of the potential applications of this technology?
Okay, paint me a picture of the future.
Well, one area where I think this technology holds immense promise is customer service. Imagine contacting a company and instead of going through that frustrating automated menu
Oof, the worst.
or chatting with a bot that barely understands your problem,
Yeah.
you're connected with an AI that can truly understand your needs, answer your questions thoroughly, and provide personalized solutions.
Okay, no more repeating yourself a dozen times
Right.
or getting stuck in that endless loop of pre-recorded messages.
Exactly.
That would be a game changer for customer service, for sure.
Sure.
What else? Where else could this technology make a real difference?
Think about education. Imagine AI tutors that can adapt to individual learning styles, provide personalized feedback, and guide students through complex concepts.
At their own pace.
Yeah, exactly.
It'd be like having a personal tutor, available 24/7,
Right.
ready to answer any question and tailor the learning experience just for you.
Hmm.
That could revolutionize education. It's not just about formal education, though, right?
Oh,
I mean, imagine AI-powered language learning apps that can hold natural conversations with you, helping you practice your skills.
in a fun and engaging way.
Exactly. That would be incredible. It would be like having a language partner right in your pocket, ready to chat whenever you have a few minutes to spare.
What about other fields? Are there any other potential applications that really have you excited?
One area I'm particularly fascinated by is the potential for AI collaboration in creative fields.
Hmm.
Imagine writers working with AI partners that can help them brainstorm ideas, refine their writing style, even generate different storylines.
Or plot twists.
Yeah.
It would be like having a co-writer who can instantly access a vast library of literary works, analyze different writing techniques, offer constructive criticism.
Yeah, that's the idea.
That could spark a whole new wave of creative innovation. And it's not just limited to writing either, right?
Right.
Think about musicians collaborating with AI to compose music, artists using AI to explore new visual styles, even filmmakers using AI to help them with storytelling and special effects.
Hmm.
The possibilities are pretty much endless. This is truly mind-blowing. It feels like we're on the cusp of a new era,
Yeah.
where AI is not just a tool,
What a creative collaborator.
a partner.
Yeah. But with all this talk of AI transforming these different fields, are there any potential downsides that we should be thinking about?
Well, it's important to remember that no technology is without its challenges, right?
Right.
And one of the biggest concerns with AI, especially in these creative fields, is the potential impact on human jobs.
Yeah, that's a valid concern for sure.
Yeah.
If AI can write music, create art, even help with filmmaking, will human artists and creatives become obsolete?
That's a big question that people are debating right now, and there's no easy answer.
Hmm.
I think it's more likely that AI will augment human creativity, not necessarily replace it entirely.
Okay.
It'll be a tool that artists and creatives can use to enhance their work, explore new possibilities, push the boundaries of their craft.
So it's not about AI versus humans,
Oh.
but rather AI and humans working together.
To create something truly remarkable.
Exactly. And I think that's where the real excitement lies.
Mm.
This has been such an inspiring and thought-provoking deep dive. We've gone from the nuts and bolts of how this technology works
Right.
to envisioning its potential impact on various fields. It's clear that multi-turn conversational RAG is poised to transform the way we interact with information, with each other, and with the world around us.
And as this technology continues to evolve, we can expect to see even more innovative applications emerge in the years to come. It's an exciting time to be live, that's for sure.
It really is. And on that note, we've reached the end of our deep dive into the fascinating world of multi-turn conversational retrieval augmented generation. We hope you've enjoyed this journey as much as we have, and we encourage you to continue exploring, questioning, and diving deep into the ever-evolving landscape of artificial intelligence. Thanks for joining us.
Until next time.